Express 5x minus 6 over x times x minus 3 in the form a over x plus b over x minus 3. Find this integral, given that 4x cubed plus 5x minus 2 is equal to 2x plus 1 times 2x squared plus px plus qx plus r. Find the values of the constants p, q and r. Part 2. Find the integral of 4x cubed plus 5x minus 2 over 2x minus 1. So that's the question then. There's a plus r here, which I'll put in the question. Here's the question then in summary form. So the first part is partial fractions. Let's have a go at that then. So here, just let the 5x minus 6 over the xx minus 3 is equal to a over x, linear factors, isn't it, plus b over x minus 3, given in the question. Cross multiply then. 5x minus 6 is equal to a times the x minus 3, more than one term, put a bracket, plus b times the x. So that's what we've got then. Let's put in x equals 3. And what do we get? 15 minus 6 is 9. Put 3 in here, you get 0. That's why we're doing it. And then 3b. So b equals 3, doesn't it? Okay, and then we put in x is 0. Or just equate constants, basically. We get minus 6 is equal to minus 3a. So that tells us minus 3a from this bracket, x is 0 here, that thing is 0. So that tells us then b, move the minus 3 underneath, 6 over 3 is 2, and the minuses cancel. So a is 2, and b is 3. So, answer then is equal to 2 over x. B is 3 plus 3 over x minus 3. So that's that part done then. Find this integral now. So I'm going to label that as I. Save me writing it out again. Part 2. So here, I is equal to the integral. We can just replace it by this stuff here, can't we? 2 over x plus 3 over x minus 3 dx is equal to, this is a log, 2 lots of, standard integral. This is a function of a function, log of something, plus 3 lots of. Let's just try writing log of x minus 3. And that differentiates to log of something goes to 1 over the something, multiplied by the something differentiated, which is 1. So 3 ones are 3, so that's fine. Plus a k, constant of integration. So there's part 2. Okay, given that that equals that then, so I'm going to copy this now and take it down. So there it is in the question, and we need to find that integral. So we're going to need to find p, q and r, aren't we, first of all, which was in the question. And then we can work out the interval. So this was part, just have a look, part B, part 1. So we need to find B, P, Q and R then. Okay. Well, let's, what should we do? We've got x cubes. We could equate x squareds, couldn't we? Because there's no x squareds here. Or we could equate x's. I'm tempted to equate x squareds just by virtue of the fact there's no x squareds on the left to see what happens. 0 is equal to then here. Now x squared, we've got 2x times a px is the x squared here, which is 2px squared, so that's 2p. We've also got a 1 times 2 here for x squareds. That's 2, isn't it? So that tells us then, that's all the x squareds on this side. So that tells us that, well, p is minus 1, but 2p equals, move the 2 over, read from right to left, and that tells us that p equals -1. So there's p. Okay, now we can proceed. Because we've got px's here, let's just equate x's now, because we know p. So 5 on this side is equal to 2x times q, isn't it? So that's 2qx. And then 1 times p is plus p. So that was the px there. So it's only 2x times q, 2q, plus 1 times p is px. So that tells us then that 2q then is equal to 5 minus, move the p over p. So that tells us 2q is 5 minus p. P is -1, so that's +1. 5 plus 1 is 6. Q is 6 over 2 is 3. There we go. Q is 3. Okay, now we need r. So we better equate constants now, haven't we? So the constants then, or x equals 0 is the same. -2 on this side. 1 lot of this, which is q. Isn't it? That's the only thing that comes out there. Plus r. Plus the r constant. That tells us then that r is equal to -2 minus q. Move the q over to be minus q. And that equals -2 minus 3 is -5. So r equals -5. So there's p, q, and r. So that was p part 1. Now part 2 tells us to work out that integral, doesn't it? Find this integral, which happens to be basically when this is moved underneath, so you just end up with this stuff here. Oh, hang on. When this is moved underneath, the r is still left there. So we've got to be a bit careful here. So part 2. So 4x cubed plus 5x minus 2 over the 2x plus 1. That, if we divide this all the way through the equation, that will be what we've got here. But we'll have just 2x squared plus px, which is minus x, plus q, and q is 3. So we'll have that there, but when we divide all the way through the equation, all three objects, we get an r here, don't we? So r is -5, so let's put minus over the 2x plus 1. Okay, so I'm going to use this stuff now. Just going to save me writing it again. We've done the algebra now, so I'm just going to do the integration here. The integral of this dx, save me writing a fresh line, dx is equal to the integral of this dx, isn't it? So let's work it out then. So here we just got the simple power rule, 2x cubed over 3, isn't it? Minus x squared over 2 raised to the power by 1, divide by that number, plus 3 lots of x for here. This is a log, so I'm just going to write log of 2x plus 1 first. Log of something, let's differentiate this in our mind's eye. Log of something goes to 1 over something, which is what we've got here, multiplied by the something differentiated. And this differentiates to 2, so 2 will come out here, so we'll need a 2 underneath. We've got -5 lots of, so let's put that in as well, plus k. And there's the integral.